Good morning, children. Today I am going to start the new unit number 2, current electricity. This is chapter number 3 in NCERT book. We have already run unit 1, that is electrostatics or static electricity, also you can say it as. And I told you that approximately 8 marks question will appear from that portion. Now we are starting unit 2, current electricity. This is chapter number 3 in NCERT book. Some of the things which we will discuss today you have already done in class 10th, but I will again be repeating it to you. So try to listen it carefully, and if you are not able to understand, again and again see the video, or you can also go through your book of class 10th. The very first thing is, what is current electricity? See, in normal routine we use the word electricity, but it is current electricity, means an electricity which is being obtained by moving charges. By moving charges. If the electric effects are shown by charges when they are at rest, that is known as static electricity, which we have already done. So now we are going to deal with moving charges. And as you all know that moving charges constitute current. So the very first topic which we are going to talk about is current. What is current? It is the flow of charge per unit time. As we have discussed earlier also, it is charge flowing through a material or a conductor per unit time, that is known as current. I is equals to Q upon T, where Q is the amount of charge. Now what is moving? Which charge is moving? Charge, you know that it is positive as well as negative. So which charge is moving? See, as we have done in unit 1, I told you that in solid conductors it is the electrons which are free to move, and therefore they conduct if they are allowed to do so, if there is some external field. But if it is an electrolyte, then positive ions as well as negative ions can also move. But here, since we'll be only talking about solid conductors, so when I say movement of charges, it is the electrons which are going to move. Now, amount of charge. Now, amount of charge and this Q should not be confused. How? See, amount of charge will be equal to N E, where E is charge on one electron. E is charge on one electron. So when I say Q, it means that I am talking about the total charges flowing in the conductor. Total charge means charge on one electron is, say, E. If number of electrons moving are N, then the total amount of charge will be NE. This many students get confused between Q and E. Q is total amount of charge, E is charge on one electron. Depending upon how many number of electrons are being transferred, you will get the total amount of charge. So this can also be written as I is equals to NE upon T. And definition can be given from the expression itself. Charge is moving per unit time is known as current. general, since current does not remain constant most of the time, then in that case, what shall happen? Then we'll go in for short duration of time. So if current is continuously changing, we'll be doing alternating current also further. Then in that case, I will be defined as dq upon dt. That the small amount of charge flowing per unit time or per unit, you can say here dt will be as small tending to 0. But the definition will remain same, that the charge is flowing in a given time. Now the unit of current. It will be equal to unit of I will be equal to unit of Q, that is coulomb, divided by time. So it will be coulomb per second, and it is known as ampere after the name of the scientist, and is denoted by capital A. And how you will define A? We'll again go back to the same expression. The current is said to be 1 ampere when 1 coulomb of charge flows through the given conductor in 1 second. So in this way, you can also define the unit. Now, we always say that current is having a direction. Current flows from, say, positive terminal to negative terminal. Electrons flow from negative terminal to positive terminal. This we have done in class 10th also. But current is a scalar quantity. Even when it has got a direction, it is a scalar quantity. The reason being that we cannot use law of vector addition and subtraction in case of current. It has got direction, but since laws of vector addition or vector subtraction or resolution or vectors, since are not applicable, cannot be applied to the additions of these, therefore current is a scalar quantity. Now we'll talk about Ohm's law. Now this also you have done in lower classes, the Ohm's law, but we'll again repeat. What is Ohm's law? He studied the variation of change in current with potential difference. He did an experiment and concluded that the potential difference across the ends of the two conductors is directly proportional to the current, or V is equals to I, and there is a proportionality constant known as R. And this condition, that is V will remain proportional to I, is under given physical conditions, because with physical conditions the resistance may change. So this R is known as resistance. Now this is a mathematical expression for finding out the resistance. Physically, what is the resistance? As the name suggests, resist. It resists the flow of charge carriers or electrons in the given conductor itself. So the opposition which a conductor offers to the flow of electrons inside it is known as resistance. And different materials have got different resistances depending upon their atomic structure. What is the unit of resistance? We can find out from here. It will be volt per ampere or this can be written as volt per ampere. This is known as ohm and can be denoted as this, known as ohm, again after the name of the scientist. Now this value of R, apart from physical conditions, that is physical conditions will certainly depend upon the type of material I just said you. So the material, number 2, it will depend upon temperature. These are the two main things on which it is going to depend, physical conditions when we are talking about. See, that means if the temperature will change even for the same material, the resistance will change. Number 3, it will depend upon length of the conductor. It will also depend upon the area of cross section of the conductor. So these are the factors on which the resistance of a given material will depend. If we take given material, then these 3 factors will remain, that is temperature, length and area of cross section. A study was being done and it was found out that the resistance directly depends upon the length of the conductor. You can remember it in this manner that if you are going to travel longer, there is more probability that will be opposed more. You can have a traffic jam or something like that. So more the length the electron has to cover, more resistivity will be offered by, more resistance will be offered by a given material. It is found out to be inversely proportional to the area of cross section. Area of cross section, more the area of cross section, less will be the resistance. Again, you can relate it to your everyday life. Like more wider the road is, less resistance it is going to offer. Like you can move around and move steadily from one portion to another, from one terminal to another. Combining these two, you will get R is proportional to L upon A. When you remove the proportionality sign, we'll get a constant, say rho L upon A. So this is an expression which tells us about the dependence of resistance on length and area of cross section. Here now, this is a new constant known as resistivity or specific resistance. These two terms are same. This is a very common question asked in Viva during the practical examination. So these two things you have to remember that they are same things, resistivity or specific resistance. Now what is the unit of resistivity first thing, and then we'll try to define resistivity. So now resistivity will be R A upon L. So the unit will be ohm meter square upon meter. So this will cancel out, ohm meter. So this is unit of rho. Most of the time students write by mistake per meter, but it is ohm meter. This is the unit. Now from here, how will you define? resistivity. Resistivity is the resistance. Resistivity is the resistance. Keep L as 1 and A as 1 meter square. So resistivity is the resistance offered by a conductor of length 1 meter and area of cross section 1 meter square. Or you can define it as resistivity is the resistance offered by a conductor of unit length and unit area of cross section. Or in some books you will get resistivity is the resistance offered by a material of cube one side 1 meter or unit length. So that is also giving you the same value. Now the resistivity is going to depend on which factors. Now here from the formula of resistivity, sometimes a student write that the resistivity will depend upon length and area of cross section also. But it is not so, since we have already fixed the value of L and A. In our definition only, what we have said, resistivity is the resistance. But whose resistance? A conductor of length 1 meter and area of cross section 1 meter square. So when we have fixed the dimensions of the given conductor, therefore these two factors will not now affect the resistivity. So resistivity will be affected only by, it will be a constant for a given material, and certainly if the temperature is being changed. So remember, resistance will depend upon these 4 factors, but resistivity will depend only on these 2 factors. So we have defined resistance and resistivity. There are 2 more terms known as conductance and conductivity. Conductance is the reciprocal of resistance and conductivity is reciprocal of resistivity. Conductivity is also denoted by sigma. So conductance is reciprocal of resistance. Conductivity is reciprocal of resistivity. Accordingly, the unit will be reversed. Like for resistance, it will become now ohm inverse. This I am telling you because this can also be written as now reversal of ohm, that is MHO. Per ohm can also be written as mho. So these are the new terms which now you are going to learn. Now this is what we have done, you have already done before also. Now we'll talk about current density. Current density. Now this is a new term. This is denoted by J and is defined as current flowing per unit area of cross section in the given conductor, and current must be perpendicular to the area of cross section. Now current density J is a vector quantity. So you put a vector sign away. Now since current is not a vector, so current density is current flowing per unit area. It is a vector quantity, and J here you put a vector sign. I, as I already told you, will be treated as a scalar quantity even if it has got a direction. We'll see when direction is to be shown in with the current, then how will you do it? That will come later. Area of cross section, because it will be perpendicular to the area. So here the vector is being given on A. So J is equals to I upon A. And certainly the unit will be ampere per meter square. See, we know that V is equals to IR according to Ohm's law, which can also be written as I rho L upon A. Now, V can also be written as E into L. So, I can write down as E into L, I rho L upon A. Here I can write down E is equals to I rho upon A. I upon A can be written as J into rho. Now, electric field is a vector quantity. J is a vector quantity. This is one relationship between resistivity and current density. We can also write it as J is equals to E upon rho. And this now further can be written as E into sigma. What is sigma? Conductivity. So in this way we have got relationship between electric field as well as current density, resistance as well as resistivity as well as conductivity. If I want to find out a relationship between current density and resistance, I can put rho in terms of resistance here also in the same manner. So we can substitute one from another to find out an expression for current density in further terms. So I think this is all for today. You can go through all this. And one thing I would like to tell you, you can go through the combination of resistors also. As you have done it earlier also, we'll do it tomorrow, the combination of resistors as well as the drift, velocity, how the electrons move in a given conductor in absence of electric field and in presence of electric